final video of this chapter, ecosystems respond to a disturbance. So disturbance is an event caused by physical, chemical, or biological agents that results in changes in population size or community composition. And there's many things: hurricanes, ice storms, tsunamis, tornadoes, volcanoes, forest fires. These are all things that can cause disturbance. We also have anthropogenic, human-caused disturbances, such as pollutions, human settlements, clear-cutting of forests, removal of entire mountaintops for coal mining, all of these things. So ecologists are often interested in how disturbances affect the flow of energy and matter through an ecosystem, whether the ecosystem can resist the impact of the disturbance or whether it can even recover. Looking at these two pictures here, we're looking at islands in Louisiana that were almost completely submerged by Hurricane Katrina, which was in August 2005. On July 17, 2001, you see this initial picture here. It shows sand dunes and lots of vegetation here. And 2 days after the hurricane made landfall, here's almost the same exact picture. And there's massive erosion, loss of sand dunes, much of the vegetation. And so what we're looking at with this idea of a disturbance is how will this ecosystem respond? What will happen with the organisms that are there? What will happen with the beach and the sand dunes and the vegetation and the organisms? Looking at watershed studies, all of the land in a given landscape that drains into a particular stream, river, or lake, or wetland. So if we're looking at a watershed, we usually have to define it sort of along mountains. So all of the water that is sort of uphill from this river will drain itself down into this river, which is opposite of the ones on the water on this side, which will drain itself away in the other direction. So there's a couple different terms we want to look at here. Resistance, which is a measure of how much a disturbance can affect its flows of energy and matter. Resilience, which is the rate at which an ecosystem returns to its original state after a disturbance. And then restoration ecology, which is a new scientific way of looking at restoring damaged ecosystems. So, resistance, we're looking at how these flows of energy are resisted when there is some sort of large disturbance, such as a hurricane or a tsunami, that kind of thing. Resilience is how well will that ecosystem bounce back. There's this hypothesis called the intermediate disturbance hypothesis, and it's saying that an ecosystem experiencing intermediate levels of disturbances are more diverse than those with high or low disturbance levels. This is the idea that ecosystems in which disturbances are rare have a lot of competition among species, and so therefore populations of only a few highly competitive species will dominate that ecosystem. When disturbances are frequent, population growth rates must be high enough to counter these effects, and so therefore that prevents species extinction. When disturbances are somewhere in between those two, when they're not rare, but they're not too common, it favors both types of populations. It favors those which compete to live there, and it favors those which reproduce to live there. And so, we end up with this, graph where we're like looking at infrequent, disturbance versus frequent disturbance, and looking at the number of species. And species number is high when we're sort of in the middle, because it's allowing two different sort of population models to be successful. Ecosystems provide very valuable services, and if we're looking at services, we're looking at this intrinsic value. So we have instrumental value and we have intrinsic value. Again, those two terms don't come up, but instrumental value is the value of the item. So we look at what we're harvesting from the ecosystem. Is it lumber? And then we can say, or is it some sort of pharmaceutical drug? What is the economic benefits? What's the instrumental value of that ecosystem. But then we also have intrinsic value, which is worth independent of any benefit that it may provide to humans. So we're not looking at what we can gain. We're just looking at sort of a moral value. We're sort of looking at this idea that intrinsically it's important for us to have a panda bear. Whether or not that panda bear provides us with anything, it's just intrinsically something that's important to us. Provisions are the term for goods that humans can use directly, so provisions are an instrumental value. And regulating services is services provided by natural systems that help regulate environmental conditions. So ecosystems help regulate conditions. So humans add about 8 gigatons of carbon to the atmosphere annually, but only about 4 gigatons of carbon remain there. And so who's taking care of that carbon? Well, natural ecosystems, the tropical rainforests, the oceans, are pulling a lot of that carbon, because if they weren't, we'd be dealing with a much, much bigger climate change problem because of all the CO2 in the atmosphere. Support systems, the support services that natural ecosystems provide, such as pollination, natural filters, and pest control. So support systems, it's sort of estimated. The American Institute of Biological Sciences says that crop pollination by bees and insects and hummingbirds and bats is worth roughly $3.1 billion in food production. So if we had to take those services that those organisms are providing and do that by hand, it would cost us $3.1 billion. And so those are sort of a good example of a support system. Healthy ecosystems filter harmful things and chemicals from the water, leaving humans with water to drink, which requires relatively little treatment. Most of us have wells around here, and our water is just filtered by going through the ecosystem, by draining its way through our soil. It's draining out a lot of the pollutants and things that we don't need. If we had to do that on our own, that's much, much more expensive. This idea of resilience of an ecosystem ensures that we'll continue to provide benefits to humans, and this sort of greatly depends on species diversity. Several different species may perform similar functions in ecosystems, but different in their susceptibility to disturbance. So if there's some sort of pollutant that kills one plant that helps put the nitrogen back into the ground, there's still several other species of plants that can still do that. That helps make the ecosystem resilient. And then cultural services is sort of a cultural or aesthetic benefit to many people. The beauty of nature has instrumental value because it provides this aesthetic value or benefit to which people are willing to pay. You're willing to pay to enter a national park. Things along those lines. There's instrumental value because people can get knowledge from these different things. So there's sort of this whole talk about intrinsic value of these ecosystems, that we just love ecosystems. It can grow out of sort of a religious belief or philosophical beliefs that the ecosystems are inherently valuable, and we have a moral obligation to preserve them. It's a harder argument to make. We understand that we need to make the argument that we need to have this intrinsic value. We need to gain, whether it's the CO2 production, the CO2 that ecosystem takes in, that we gain medicines, that we gain wood, that we gain different things. But there's sort of this intrinsic value that we can't really put a price tag on, but it's significant enough. There's enough research to say that it's important that we have time in nature, that it's good for us as people, that it's good for our soul, that it's good for people that spend time in nature. It definitely helps regulate them and help benefit them. So although you can't put a price tag on it, it's sort of a significant part. This sort of takes us to the end of chapter 3, looking at these ecosystems. And like I said, learning those cycles is going to be really, really important to this chapter, making sure we know that. And I understand this idea of these food pyramids is also going to be a really key idea to this unit. So we want to make sure that we take some time to master those two major concepts.